Let's look at streams in a little bit more detail, and I'm going to answer some possibly unanswered questions from the last video. First of all, stream is basically, you can think of it as a new view of the collection. A stream is always something that has a source. In this case, the source is a collection, it's a list of people. So a stream in Java 8 comprises of basically three different elements. The first one is a source, which provides the elements on that conveyor belt, on that stream, right? There's always have to be a backing collection. It's a source. It's the first element, the first part of a stream. The second part of a stream are all the operations that need to be performed on that stream. So here you see there is a filter operation that's performed on the stream. You can have multiple operations that are performed on it. And then finally, we have a terminal operation, the end condition. So here, this is a for each. So this is the end condition. This is what causes the stream to do its thing. This is what causes the stream to act. Unless you have an end operation, the stream doesn't even get started. All right, I'm not going to go into the details of this because, again, like I mentioned, it's a separate topic in itself. But you need to remember that these are the three different parts of a stream. I'm going to give another example. So let's say I stream through this again. People.stream. Let's say I do just this, right? What I get back, let's say I were to assign this to a local variable. What I get back is a view of this collection. You can think of this as a way of looking at the people collection. Now nothing happens. Just by executing this statement doesn't mean that there is an iteration that happens across the collection. Now what I could do is also put some operation on top of it, right? We had this filter over here. Let's say I do just this. Now, if this were to execute, again, what we are doing is we are setting the operation on the stream. It's like you have asked a worker to sit at a particular position on the assembly line, but we haven't even started the assembly line yet. However, if you were to add a terminal operation, for instance, there is the terminal operation called count, which basically provides a count of elements in that stream. So this is where the stream ends. So this provides a result, which is the number of elements at this point in that assembly line, at this point in the stream. Now I can't chain anything on top of this because what we have here is a number, which is a count. So I can't have any other methods here. So what does this do? This is a terminal condition which starts the stream, and all these collection elements are going to go through. And this is a filter which filters with the last name that starts with the letter C, and then this returns a count. Now what I can do is I can assign this to a local variable called count. And now let's say I were to do a print of the count, and let me comment this thing out. And now if I were to execute this, I'm going to get the count, which is 2. So it's basically started the stream and it has gotten the count. Now let's say I pick the last name that begins with D, and now the count should be just 1 because it has to pick only Charles Dickens. So if I were to run this, I get the count as 1. So this is another example of a stream. And again, what you should remember is that each of these operations take in lambda expressions, and these are the lambda expressions that you should be quite familiar with now. You can use these to declare what needs to happen for each element in that stream, and then you just have the stream execute them. Now, one of the things that I mentioned in the very beginning of this course is that lambda expressions enable parallel processing. Now, what is that and how does it enable it? Now you see here, stream is basically a way for you to take the iteration out of your control, right? It's not an external iteration now, it's an internal iteration. You're having the runtime do the iteration, and you're just declaring the intent. You're just saying, I want this filter to happen, I want this for each to happen. You're just saying, do that for every element, but you're taking control of the looping out of the developer's hands and into the runtime. So the advantage of doing something like this is you can have different portions of the collection handled in different processors. If you have a multi-thread, multi-core processor, you can have portions of a huge collection, for instance, execute these different things in different cores. You can think of it as two separate assembly lines. We have a bunch of different elements, have one portion of it go to one assembly line and another portion go to another assembly line, right? You can have that happen. And the way to do this is using another method here on the collection called parallel stream. Now, what does this do? It returns a possibly parallel stream with this collection as the source. So it's exactly like the stream, but this could potentially return a parallel stream if it feels that multiple cores could be used to make this faster. It could potentially split the collection into multiple streams and do the exact same thing. The result is not going to change, but it could potentially do things in parallel. So this is the advantage of the functional programming model that Lambdas enable. Again, I recommend you look at collections and streams in Java 8. This is a very powerful new construct, and there's a lot of stuff to learn here. So definitely check that out. But this is where I'm going to wrap this video, at least in the context of Lambdas. You can see how Lambdas enable you to set up different steps along a stream and have different operations applied to them.